What do we use to solve for an exponent? Logarithms. Okay, so as soon as it pops back up, since we use logarithms to solve for exponents, we're going to take the log of both sides here. So we'll do the log, or can I do natural log? Does it matter? We can do either. Sometimes I choose log, sometimes I choose natural log. Natural log is only 2 letters. Log is 3. It really doesn't matter. Okay, I'm taking the natural log of both sides. Well, what can I do with the x now? If we were expanding it, what would you do with the x? Yeah, it would be we could pull it out in front and multiply by it. So now, can we solve for the x? Yeah. X equals natural log of 5 divided by natural log of 2. All right, you have, and you've already used it because we've evaluated natural log and log on our calculator before. But go ahead and evaluate natural log of 5 divided by natural log of 2, and see if that's any different than log of 5 divided by log of 2. Okay, what's the approximate value of natural log of 5 divided by natural log of 2? You may get 2.32? Okay, 2.32. What did you get when you did log of 5 divided by log of 2? Same thing. Okay, did y'all close your parentheses here on your calculator? Okay, make sure you close your parentheses and then you should be okay. All right. Any questions about how to solve this? When we're solving for an exponent, we use logarithms. So we introduce something that wasn't there. Whatever I do to one side of an equation, I must also do to the other. And then we can use what we know about logarithms to solve. You try this second example, please. I did. What's wrong, Carolyn?
I'm so lost right now, sorry. I thought I was wondering why we're looking at the sheet and doing that.
Because in just a moment we're going to use those word problems as examples. Exact answers, this is how you would leave it. Log of 12 over log of 3, or natural log of 12 over natural log of 3. It just depends on what you chose to go with here. If you're asked for an approximate answer, you should have gotten 2.26. Is that what you got? Yay! Okay, so this is exact. This is exact. And this is approximate. And as you move along in your mathematical career, you may be asked more to leave it in the exact form than to give the approximate. Okay. Oops, skipped one. E to the x equals 10. Once again, we are solving for x, and this one's already base e, so which one should I naturally choose? Log or natural log? Natural log. So I'm going to take the natural log of both sides. Okay. And we can multiply x out in front. Now, what did we discover the other day that the value of natural log of e was? 1. So, 1 times x is just x. So all we have to do is punch in natural log of 10 on our calculator. That's the exact answer Natural log of 10. Oops. And the approximate answer would be what? 2.30. 2.30. Okay. Now we're going to go back to this worksheet. We already did A and B when we were looking at exponentials. And C, I said we're going to save part C till we get into logs, because that's what we're going to use to solve these. So now we're going to tackle part C. So the equation you already have here is that the population with respect to time was equal to the initial that we were given, the 50,000. And it's decreasing, so it's 1 minus the 0.025 to the t, where t represents the number of years. Is that what you have? Okay. Well, now we want to know, when was the population of this town 100,000? So we want to know, when did it equal 100,000? Well, did you notice that all those problems we just solved were in exponential form? A base raised to an exponent equals an answer. That's all we had. We didn't have anything extra. This one has something extra here. How would I get rid of that 50,000? Divide it out. So if I divide this side by 50,000, I need to divide this side by 50,000. Okay, so what I get is 2 equals 0.975 to the t. Can you solve that now?
Wait, how did you get
1 minus 0.025. So solve for time now. So to solve for time, we would do what we've been doing on every single other one. We take the log or the natural log of both sides. And when we do, the t comes out in front. So we do natural log of 2 divided by natural log of 0.975. And we get approximately, did you get negative 27.38 is approximately equal to t? Did anybody do it besides me? Okay, you got that? Awesome. So what does that negative mean?
Decrease, or sort of, yes, no?
Kind of before. So it's 27.38 years ago. Time before now. Time before now. Does that make sense? Okay. All right, you try part C of example 2. We should have the equations already written there. You just have to go plug into what we already have. All right, what'd you get? 11.77. And this would be hours, right? Okay. Let's look at the last one example on this page that we didn't do was part C. And this time our equation was the amount with respect to time is equal to 5 was the initial amount, its half-life, and it's raised to the t divided by 20. And we want to know this time when it will be less than 1 gram. So that's the equation we're dealing with. We want to know where it'll be less than 1 gram. First thing I have to do is divide that 5 out. And then take the natural log of both sides, and when I do, the t divided by 20 comes out in front. We get natural log of 1/2 is less than natural log of 1/5. Well, the natural log of 1/2, remember natural log is base e, and e is 2.7. So the natural log of 1/2 is actually negative. So when I divide by that negative right now, what does it do to the inequality? Switches it. So that becomes natural log of 1/5, which is 0.2, divided by natural log of 1/2, which is 0.5. And then to solve, what do I got? 20? Multiply by it. So I'm going to multiply both sides by that 20. So after I do that division, I can multiply by the 20. And so my time would be 46.438 years later. So anything after 46.438 years, there'd be less than 1 gram. Okay, your homework is 2 through 22 even, and omit number 16. If it says use change of base is exactly what we've been doing. It's just a formula that gives you the shortcut, but it takes out the understanding. So if it says use change of base, just solve the way we solve. Okay?